Hey guys, we're going to do test corrections for test 9. So, once again, you get 3 scores on this test. This first section, you get a total of 30 out of 30 points. For this section, there's a total of 30 out of 30 points for this section. And last but not least, 30 out of 30 points for this section. Okay. So you can calculate your score by adding up your numerator and putting it over. The whole test should be out of 90 points. So let's take a look. Let's see how you did on the multiple choice. The resting pulse rate of someone in fitness with a lower rate indicative of greater fitness. So they're saying the average person is 72. So the lower it is, the better the fitness. Lower, better fitness. Okay, that's important. So now it says a random sample of 25 males currently enrolled in a facility that was selected, the mean resting rate was found to be 80. So that's your sample. Okay, but what is your sneaky suspicion? They're saying the experimenters wish to test if the students are less fit on average. So they believe they're less fit. Well, if they were more fit, it would be lower than, the true proportion would be something lower than 72, but they believe they are less fit. So they believe that they would get something higher, and they actually did get something higher. Okay, so this is the accepted truth. We have a sneaky suspicion as something higher than the accepted truth. So we should never select things, these always have to be the same number, and we don't put an X bar there. So we're looking at E as our answer, because if they're unhealthy, that would be greater than. Let's look at question number 2. I think we had some sample questions like this. Possible type 2 error. Well, that means you walked through door number 2. Well, what happens when you go through door number 2? You fail to reject the null when you should have. Right? So the null is false, and you should have rejected it, but you just didn't have the evidence to do it. So kind of referring to the last question, if you failed to reject the null, you actually stuck with H sub O, right? So you actually concluded that the students have the same fitness as average. So you concluded the students, no, I like this one. You concluded the students have the same fitness. You failed to reject the null, which means you didn't reject it. So you actually concluded they do have the fitness of the 72, which is the same. Have the same, have the same. Okay, so I like each of these. Have the same fitness. Have the same fitness. And I don't like these. So if I walked through door number 2, I failed to reject the null. I didn't reject the null when I should have. So now we also know, since I made a mistake, that the null's false. So let's take a look. Conclude that the students have the same fitness when in fact they are less fit. Yes, your sneaky suspicion was right. They are in fact less fit. So this is our answer B. Okay, let's keep moving. A significance test gives you a p-value of 0.04. What does that mean? Well, we assume alpha is 0.05, and we compare alpha to the p-value we get. So we see here that 0.04 is less than 0.05, so we would reject the null at the 5% level. What does A mean? Well, notice they could change this level of the test. They could change alpha to this, and that means we're only going to reject it if it's less than 1%. Well, notice this is greater than 1%. So if the test had an alpha of 0.01, we would not have rejected the null. So that's what's wrong with A. We would not have rejected the null at a 0.04 of a p-value because 0.04 is not less than 0.01. Okay, let's take a look at question 4. A significance test was performed. H sub O is mu equal to, and H sub A is mu is not equal to 2. The test statistic is 140, so that would mean not 1, not 2 standard deviations, but somewhere in between there. So we get a z-value of 1.40. What is the p-value for the test? So how does the calculator do this? This goes all the way back to chapter 2. What is the probability? What is the area under the curve? Well, we know this is symmetrical, so we can find the area here under the curve. It should be symmetrical to this side of the curve, right? These are symmetrical. So we can look at the number negative 1.4. The area to the left of negative 1.4 is, I have exactly negative 1.40, right? So I'm looking at this number 0.0808. So the area under this curve is 0.0808. That's my p-value. And also, notice this is a two-sided test. So not just greater, but also if it was as least as extreme. So you also would have to include this p-value, which we already actually looked up. We know the p-value is 0.0808. So what is the p-value of this test, the two-sided test? That would be the total of the two. So if we added those together, we get 1616. We found our answer. 1616 would round to this. Our final answer is A. Let's take a look at the other question. So question number 5 states, if we had an approximate 95% confidence interval for mu and it was calculated, then that means we're 95% confident that the interval ranges between negative 73 and 1.92. Now, based on these 15 observations, the distribution is normal, the hypothesis is this. Based on this confidence interval, what happens? Okay, so based on this confidence interval, we're looking to see if the truth lies somewhere in between here. And it is. 0 is, our truth is within the variable, within the interval. So we should not reject it. In fact, this evidence supports it. So we should not reject the null. We should not reject the null. So we should not reject the null. At which level, though? So notice a 95% confidence level is similar statistically to leaving alpha at 0.05. So if alpha is 0.05, it's similar to the 95% confidence interval. Final answer is B. Okay, 6. The most important condition is the randomness. We've been talking about this a lot. The other ones are super important, but not as important. We don't need things to be exactly normal. We rarely get the population standard deviation, but it's really nice if we've got it. We've done plenty of studies when we didn't have all 30. Okay, so that's kind of a reoccurring question. 7, to increase the power of the test. Now, we just saw that happen a minute ago with this increasing a significant level. So let's say they set the significant level at 0.01. Okay, so that's the level of the test. So like, you know what? We want to make sure it's very, very rare that it occurred. Okay, so we want to reduce committing a type 1 error. So we want to set alpha at 0.01. Well, what does that mean? Let's say your p-value was pooped out of your calculator 0.04. Well, right now you're sitting there going, crap, I can't walk through door number 1. I can't reject the null hypothesis because this p-value is greater than my alpha. So what if you went back and convinced your boss to increase alpha? If we reset alpha back to 0.05, what it normally is, then we can walk through door number 1 because 0.04 is less than alpha if alpha is 0.05. So by increasing the significance level from 0.1 to 0.05, we were able to detect, therefore increasing the power of the test. So my answer is increasing the significance level would allow me to increase the power of the test. Okay, that was fun. Last one, a medical worker is working on a new treatment of cancer. After diagnosis, the average survival time is 2. In early stages, she tries treatment on 3 subjects. Their average was 4. Okay, so I can't put 4 though. I have to say we have a sneaky suspicion that our treatment is better, that our patients are surviving longer. Okay, so what does this mean? After running the survival time, they're saying the survival time doubled, but they didn't get a significant, they're not statistically significant even at the 0.10 level. What does that mean? That means they finished out the test, and let's just give a reasonable guess. Let's say the p-value that they generated was 0.14. Now, if alpha was 0.05, we can't walk through door number 1 because it's greater than 0.05. We could try to increase the significant level, but even if we increased it to 0.10, notice 0.14 is still greater than that significance level. So, this one, the results may not be significant at the 10% level, but they are quite significant at the 5. That would never happen. If they fail to meet it at the 10% level, they will continue to fail because it means that the p-value is just more probable. That's a more probable outcome. So why would you get a probable outcome? The answer here is C. Although the survival time has doubled, think of this in relative terms. It's actually just 2 years more. So the number 4 is not that much bigger than the number 2. Yes, it's double, but it's only 2 more bigger than that. And the likelihood of that occurring is actually rather likely. So that's how we change significant levels to sometimes try to reject the null. Thanks for joining us. Check out the other videos for the free response.